I've spent a couple of years now avoiding the subject of sprite atlasing, but I'm running out of excuses and it is going to be relevant to something that I do want to talk about eventually. So hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about how you can take a bunch of individual sprites and combine them into a single image, which you can then do basically whatever you want with. Sprite atlasing is not something you're going to have to do in games very often. This is almost exclusively the domain of if you want to like write some external tooling to allow you to do something outside the game, or to allow you to assist in other parts of game development. For normal everyday use of GameMaker, this is completely unnecessary, but I like to hear myself talk, and there is a particular subject which people have been asking for me to cover since prehistoric times, which Sprite atlasing is going to be relevant to. So let's do this. So if you don't know what exactly I'm doing, GameMaker will actually do this for you. Unfortunately, it does not give you a way to like access functions to do it at runtime, but when you run your game, GameMaker will take all of the sprites in your game, and it will pack them onto what is known as a texture page, and that is going to ultimately produce a single image, which is going to look something like this. And this is just how the GameMaker runtime stores all the sprites in your game. We're basically going to try to imitate this on our own. Now, a full complete sprite packing algorithm is a little bit complex, but there are intermediate steps you can take, which will be much easier to write in exchange for, like, optimal texture packing. So just like I did last year when I talked about palette swapping, I'm going to separate sprite atlasing into multiple videos. This first one is going to cover a very easy to write but somewhat spatially inefficient version of sprite packing. And in a couple of weeks, I'd like to make a second video on a more advanced sprite packing algorithm, which is going to be more like what you would see with GameMaker's texture packer or some other generic texture packer that you can find out on the internet. So what we're going to have by the end of today is going to be something that looks like this. All of the textures that you might want to pack together. They're basically going to be arranged in a grid. There is going to be wasted space. In some cases, particularly with this tile here, there's going to be a lot of wasted space. But it is going to work. And if all your sprites are approximately the same size, maybe that's okay. And later on in a future video, we'll look at cutting down on that wasted space a little bit. So, by the way, I'm going to be doing this in GameMaker, obviously, but this is a pretty generic algorithm, and if you came here looking for how to do sprite packing in some other system, everything I say here should still apply. GML is pretty JavaScripty, and therefore, if you're remotely familiar with JavaScript, you should be able to take what I write here and like do it in some other language. So in my sample project, I've got a handful of sprites. There's what you saw before, and there's also a couple of trading card sprites from Wizarducks, which I'm making use of here specifically because they're all the same size. So I've got like 20 sprites that are all the same size, and maybe like 10 that are different sizes. And if I go into, let me close all these because they annoy me. If I go into my obj_packer here, we're going to start out in our create event initializing basically just an array of these like trading card sprites. I'll go ahead and add in the rest of the sprites later on, but first let's think about what we might do to put these all on a single texture atlas. So let me go and collapse that because I don't need it. Let me go and create myself a script, and we can call this let's call it pack sprites v1, and we're going to go v1, v2, v3 because there's going to be multiple different ways that we're going to be doing this. So this function is going to take an array of sprites as its input parameter, and it's going to produce an image. So if you've thought about this problem for about 5 seconds, you probably had the idea that what if we just, to put these sprites onto a single image, we just iterated over this array and just like drew them all out one by one in sequence. And that is a valid way of doing things. There's a couple things we'll need to do to get there. First, we're going to need to like figure out the total width. I'm going to do this horizontally. You could do it vertically if you want, but we're going to need to figure out the total width of all of these sprites added together. And we're also going to need to figure out like the max height of all these sprites added together. For what I'm going to start with, all these sprites are like the same size, so you could just take the dimensions of one and then multiply it by however long the array is, but we're going to assume that that is not necessarily going to be the case. So if I initialize var w to 0, var h also to 0, we could iterate over for var I equals 0, I is less than array length, I plus plus, We could say of our sprite equals sprites index I, because I don't feel like typing out sprites index I every time. And we could say w plus equals sprite get width. And we could say h equals the max of the existing h, and sprite get height. So we're going to add together the widths. We're going to find out what the max height is, and then we're going to, apparently I hit the insert key at some point. We're going to figure out what the max height is, and that's going to be the dimensions that we need our sprite atlas to be. So next, we're going to actually create a surface for us to actually draw these onto. We can say surface equals surface create width and height. If anyone is joining us from outside of GameMaker, surfaces are basically temporary render targets. If you want to draw something onto like some temporary frame buffer. I do know that the concept of things like surfaces do exist in other programming languages, programming environments, OpenGL, DirectX, what have you. But I don't know exactly what the terminology is called, unfortunately. Anyway, once we've done that, we can surface set target to start drawing onto it. When we're done, a few lines down, surface reset target to make sure that we don't forget. I'm going to want to draw clear alpha to fill it with black pixels that are 0% opaque. And then we can simply iterate over every sprite in the array a second time and draw them onto a position in the surface. We're going to need to keep track of our current x. I'm going to say x equals 0. We can also do the same for y, even though we're not actually going to be doing anything with y. We're just going to be doing this like in a line horizontally. And then if we iterate over this array again, and I'm just going to copy and paste what I wrote the first time because I'm lazy and I don't feel like writing it out, we could draw sprite subimage 0, xxyy, and xx plus equals sprite get width. And then that will move us along to the second one. If you do want to like also extend this atlasing technique to like every single sprite, every single frame in a sprite, because sometimes you might have more than one, you'll need to possibly do a second loop here. You'll need to possibly multiply sprite get width by like the number of frames in a sprite to get the accurate width and height at the top. Anyway, that's all we need to do. The last thing I will do is I'm going to, when I say surface reset target, we will sprite create from surface to turn this, the volatile surface back into a sprite so that it'll like stay there. That's pretty easy. We'll take the surface. The x can be 0, y can be 0, width can be the width of the surface that we defined earlier. The height can be the height of the surface that we defined earlier because we want the whole thing and not just like a part of it. Remove background. I'm going to set that to false. Smooth, false. I don't even know what that argument does, honestly. It's been there since like ancient history of GameMaker, and I don't think anyone's ever used it on purpose. The x origin and y origin can just be 0, which doesn't really matter. This is going to be our, let's call it final atlas or something. We will need to free the surface when we're done. And we can return final. We can return the final atlas. So this is a function which will take an array of sprites as an input. It will assemble them into a, I didn't spell this right, did I? It will assemble them into an atlas as a sprite. It will return that, and then you can do whatever you want with that. So I'm going to, in the create event of obj_packer here, I'm going to pack sprites v1. The array is just going to be this array of sprites. If we save this to a variable, we can keep a reference to that for later. And also, I want to actually draw that on the screen. So in the draw event of this sprite packer object, just draw sprite atlas subimage 0. The x can just be like the x and y of this object on the screen in the game world. And I do actually have this in the game, right? All right, I did go and add that. So now if I run the game, we are going to see that we're going to get pretty much exactly what you expected. So all of these like artwork pieces of like bird cards from Wizarducks are going to be just lined up one after the other. It will work. If you really just need something quick and dirty, it's fine. If your sprites aren't that big or if your sprites aren't that numerous, this is fine. There's no point overcomplicating things. However, GameMaker's GameMaker's surfaces are only allowed to go up to a dimension of 16,384, which is 2 to the 14th, I believe. And these card sprites are 160 pixels wide, which does mean that if you have more than 102 of these card sprites in your array, GameMaker will crash. If your sprites are bigger, you'll be able to get away with fewer of them in your card sprites array before the game will crash. If your sprites are smaller, then you might get a few more. But while this is probably fine for very limited use cases, where either you have a lot of small sprites or you just don't have that many sprites at all, if you do actually have a large number of sprites that you want to pack, this is going to stop being useful pretty fast. By the way, how exactly many of these sprites are there? So, like, if I were to just say draw text, let's say x, y minus, like, 32 or something, and we could say, let's just print out, like, we'll just draw text of the dimensions of this atlas on the screen. GameMaker, why are you not liking this? Is this an actual error, or is Feather just, like, being weird? Oh, I'm missing a closed parentheses there. Alright. Anyway, this atlas is going to be 2880 by 90 pixels, which is a little lopsided. But in the grand scheme of things, this isn't a lot of sprites and they're not very big. 2880 is not anywhere close to the 2 to the 14 maximum dimension of GameMaker surfaces, and there is an argument to be made for if it's stupid and it works, it's not stupid. So if you want to see something that's a little bit stupider, we can go and start adding in the other sprites to this array. So I'm going to prepend them to the beginning so that you can actually see them. But let me just go and copy some code from my sample project so that we can just add in these other more irregularly sized sprites. And if I run this now, we will see that it'll still work. And it will also work, like, for sprites that are not all the same size. The atlas has been extended a little bit in the vertical direction because some of the sprites are a little bit taller than 90 right here. And the ones that are narrower than the card sprites, they will just be packed together nicely. And we can also see that the maximum dimensions have been expanded to 3417 from 2880. Alright, so let's imagine that you do actually have a lot of sprites and you are actually worried about coming up on the 16384 size limit of a GameMaker surface. And what if instead of just lining these up in like a one-dimensional strip, we arrange these sprites in a somewhat more two-dimensional grid? And by that, I mean something that's more akin to what I showed at the beginning of the video in the sample project here. So I did mention that this is not extremely spatially efficient, and you might find large gaps between sprites that might not like make very good use of the total space. And again, I will make a second video with a more advanced version of this algorithm that addresses that at some point in the future. But let's take this one step at a time and think about arranging these into a grid. So all of these sprites here in this texture atlas are arranged at a regular interval. And to make sure that they don't overlap, that size of each of the cells is going to be the maximum width of every sprite in the array and the maximum height of every sprite in the array. I know that some of you are going to have ideas for how we can like squeeze these together more efficiently, but again, later. So let me go and make myself a second script, and we can call this pack sprites v2. And this is also going to take an array of sprites as its input. So the first thing I'm going to want to do is figure out actually the largest width and largest height of every sprite in the array. And we can do that in a very similar fashion to like adding up the total length over here. And in fact, I think I'm actually going to copy and paste some of this code and just change it. So I'll call it largest width equals 0 and largest height equals 0. We can iterate over the array. And we're not going to like add up any widths or anything like that, but I am going to take the largest height and say the largest height equals the max of the previous largest height and the height of the sprite. And we can also do the same thing for the width. This is a pretty common routine to find the largest number in a collection of numbers. So to make this grid look like at least somewhat satisfying, I'm going to attempt to keep it a square. And if I like increase or decrease the number of sprites that are going to be packed here, we can see that as we like fill it in, it's going to the algorithm is going to sort of resize in a way that will keep things approximately a square. So I'm going to start by figuring out the total area that will be taken up by every single sprite in the array, or I should say, I'll figure out the total area that would be taken up by this many sprites of the maximum dimensions, and that's going to be like the largest possible size that we need to definitely contain every single one of these sprites. I'm also going to, because I'm looking at my sample project, and I'm going to be typing out array length like 50 times. Let's just say var sprite count equals the number of sprites in that array, and we can just reference that instead of typing out array length as many times as we'll need to. Because that will start to annoy me. So the area of our atlas, we can say atlas area is going to be the largest width times the largest height, which is going to be the area of our theoretical biggest sprite, times our sprite count. And real quick and dirty, if you wanted to make that a square, we can say var atlas side length equals the square root of the atlas area. So if you wanted a perfect square with the area that you would need to contain all these sprites, this would be it. Doing a little bit of geometry here. This is probably not an actual useful number to us because in practice, unless all of your sprites are perfect squares and you have a square number of them, or otherwise you get cosmically lucky with the numbers that happen to go into this, you're going to end up with a side length, width or height that's going to like chop off some sprites halfway through, and it's not going to be that useful as a texture packing algorithm. So instead what we can do is we can say atlas width is going to be the atlas side length divided by... So we're basically going to take the side length and round it up to the nearest whatever the largest width is. And we can do that by dividing atlas side length by the largest width. We can round that up with the ceiling function, and then we can multiply that by the largest width. If you've never seen anything like this before, being able to round or seal or floor to any old arbitrary value is a very handy piece of math that comes up all over the place in computer science. I would definitely recommend being familiar with code that looks like this if you want to round to the nearest like multiple of 10 or the nearest multiple of 2 or even the nearest power of 2 if you were to use something like a square root or a log function in here. Anyway, this is going to round the side length to the nearest largest width, and that sounds a little weird to say out loud, so should I just call it something like the theoretical sprite width or something like that? That sounds a little better. That still sounds a little weird. Anyway, since this is going to be a perfect multiple of the sprite size, from here it should be pretty easy to figure out the number of columns that will go into this. So like the number of sprites that will go in a line horizontally. And we can say atlas columns is going to equal atlas width divided by the largest width. I realize that dividing by and multiplying by and dividing by again the largest width here seems a little bit like redundant, but we do need both of these values. We will also want to be able to figure out the number of atlas rows, which is going to be how many of these rows are going to be stacked on top of each other. And to do that, we can say atlas rows equals the sprite count divided by atlas columns. We are going to want to round this up to the nearest, well, in this case, it'll just be the nearest 1. Because you don't want there to be any situation where you have, like, half of a row that's been cut off, like, midway through. So we're going to want to round that to the nearest integer. And lastly, our atlas height is going to equal total rows times largest height. Oh, it's atlas rows. In my test project, they called it total rows, but anyway. At the end of the video, I'll break this on purpose and show things that can go wrong in different ways if you don't, like, do some of these steps. So, we now have the width and the height of the surface that we need. This is analogous to just W and H that we got in the simple for loop over here the first time around. It's not like a lot more computationally complex. Like, it's not going to be a lot slower to run. But it is quite a bit more math. I suppose we can say our atlas is going to equal surface create. The width can be the atlas width, and the height can be the atlas height. We will surface set target, and sometime farther down, surface reset target. Always do these things in pairs. And before we actually draw anything onto it, let's draw clear alpha c underscore black. And a transparency of 0, not 1. It is like getting to the end of the year, and it is getting colder in here, and my fingers are like not happy about being cold, and my typing skills are degrading farther than they like ordinarily would be in the summer. Anyway, if you'd like, we can also go and just like reuse the same like sprite create from surface width, height, whatever code from the first time around, and then just free the atlas and then return the sprite. That's just kind of boring boilerplate stuff that we'll have to do eventually. It's not the fun part of this. So there's a couple ways you can go about doing this. You could keep track of the positions of every sprite that you draw by like keeping a running total of the X and the Y and the width and the height. Much the same way that we did the first time around. We could also just use a little bit of math to figure out the location of each sprite in the grid. And honestly, all else being equal, I'm going to do that because I feel like that's just more interesting. If you want to locate your sprites by keeping the running total of the X and the Y and whatever, be my guest, I'm just not going to do it. So let us once again iterate over this array. And we are going to for each sprite in the array, we're going to do something. So the column for the sprite is going to be equal to I, our index counter, mod atlas columns, and our let's say the row of this particular sprite is going to be I div atlas columns. You could also use the percent operator for modulo division. It's the mod keyword, and I don't really know why, but I kind of have always liked typing it out like the whole word. Maybe because it's like the same number of letters as div, which is for integer division. Anyway, we can then say this X is going to be this column multiplied by the largest width, and this Y equals this column multiplied by the largest height. This is going to give us the actual position on the surface that we want to draw the sprite at. And to draw the sprite, we can say draw sprite subimage 0. X can be this X, and Y can be this Y. And this should be all we need. If I run back to the create event where we did this the first time and say pack sprites v2 and run the game, let's see, are we going to have this come out the wrong way? We are not going to have this come out the wrong way, which probably means that I like messed up a row or column index somewhere in here. I did mess something up, and that is going to be that I said this column twice, so this X should be this column times width, this Y should be this row times height. We are going to just pretend that didn't happen. And now when I run this, we have all of our sprites arranged in a grid. There is some space between them, which is not 100% efficient. But I think it's good enough for now. We can see the dimensions of this are 800 by 768, which is definitely not a perfect square, but much closer to being a square than our original version was. In my sample project, I just had like a white rectangle being drawn behind the whole thing, which handy for visualization when I was testing this out so that you could see like where exactly the boundary of the image ended and stuff like that. But here we don't really need it. So this will work. I'm going to just get rid of some of this extraneous white space here. This will work if you feed a different number of sprites into here. So I'm just going to like comment out a bunch of these and see what the square looks like, it will come up. This one was a lot closer to... Oh, this one actually is a perfect square. That was definitely just a coincidence. Anyway, not bad for just a, what, less than 50 lines of GML? Oh, you know what I can do? Instead of just, like, drawing a rectangle behind the image, I can just, like, fill... I can just fill the surface with white instead of, like, transparent black, and then we'll have, like, the sprite won't be opaque and we'll be able to see, like, the size of the image and that kind of thing. Alright, not bad. Anyway, this is definitely better than V1. It will try to keep everything in a square, so you will be much less likely to run into problems with sprites that have a dimension that's hilariously large. It's still not perfect. Obviously, it will waste some space. If you're working with sprites that are all, maybe not exactly, but sort of the same size, like maybe you have a couple sprites that are like a couple pixels wider or taller or shorter than some of the other sprites, then the amount of wasted space in this sprite packing algorithm should be negligible. And on the whole, it doesn't have to do a whole lot of math to figure out where everything goes, so it's pretty efficient. Most of the cost of this algorithm is going to be in actually like drawing the sprite and then copying the surface data to a final image sprite. If that's all you need, then if it's stupid and it works, it's not stupid. So a couple more things about this. I did say that I would show what happens if you like don't floor or seal or otherwise correctly round any of the values in here. So if I were to not round up the number of Atlas rows, you can probably guess what kind of problems this is going to give us. Here it didn't actually do anything because we have enough sprites for like a perfect square, which, yeah, alright, let me put those back in. So, now if I do this, we can see that the bottom row is chopped off because we haven't, like, rounded up the number of rows to an integer. So we're going to end up with, like, 5.5 rows or something silly like that, and any sprites down here are going to get chopped off in weird ways. And similar things will happen if you don't round the sprite width, although it will cascade through the rest of the algorithm and have some other kind of weird effects because like the Atlas width and the number of columns are used in other calculations elsewhere. So errors will seep into other places in the code. We can see that we've got a bit of a like disjointed like stair step pattern, as well as having a bunch of sprites chopped off in the middle in weird ways. Maybe not completely ideal, so let's not do that. And then you already saw what can happen if you like mess up the div and mod and the row and the column when you're trying to index these. So I don't think I have to show that again. So some other bits about this before I go. Generally, if you're going to do something like this, you would want to return not only the final image itself, which isn't terribly useful without some metadata telling you which sprite went where, but you'll probably also want to keep track of the X and the Y that each sprite ended up, like build an array of the different sprite positions and that kind of thing, and you'll want to return that with the sprite atlas information. Do I want to do that now? I don't really feel like doing that now, but I feel like I should. So let's say var atlas metadata is going to be array create based on the sprite count. So we'll have an array, one for each of these sprites, and atlas metadata index I. We can put a struct in there, which is going to contain a few things. One can be a reference to the sprite itself. Because you probably want to know, like, what sprite this particular bit of metadata belongs to. We could also say X is going to be this X, Y is going to be this Y. If you'd like, we can also set something like width equals largest width and height largest height. Keeping track of the width and the height of every sprite is not the most useful here, but in other versions of the sprite packing algorithm, it might be. Particularly if you go like really advanced with this and like trim white space off the sprites the way the GameMaker texture packer will. If you do that, you'll probably also want some additional information about like the amount of like cropped space, but that's definitely not something we're going to be doing today. And lastly, instead of just returning the sprite, we can return a struct which is going to contain metadata, can be the atlas metadata, and the sprite, the like atlas itself, can be just that sprite. And now when we read that back, we can say something like atlas info equals that, and then atlas, like the sprite itself that we're drawing, equals atlas info dot sprite. It was called that, right? It wasn't. It's wild how I'm able to like do anything when I can't remember the name of a variable between one code window and another. Anyway, this will come out to be the same thing. It will just produce a little bit more information about each and every one of these sprites. Like, if you wanted to, you could, like, I don't know, draw a list of all the sprite names and positions and that kind of thing, or you could use that for something else. All right. So I think that's enough for me for today. I'm going to end this off here. My name is Michael. I like Wizards and Dragons and making games. If you want this code, you can look for the GitHub repository down in the description of this video. I've also got on my itch.io page a GameMaker extension, which is the more advanced version of the sprite packing algorithm, which you can use if you just don't really care about implementing it yourself and you just want something that works. It does have both a version written in GML and in C++ via a DLL, which does perform somewhat better. Anyway, I like to make videos on weird stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. I like talking about a lot of shader stuff and 3D stuff, and also, honestly, whatever else catches my attention at any given moment. I have a Patreon, links to which can be found in all the usual places, and if you wanted to contribute to these videos being made, I definitely would appreciate it. Otherwise, I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Pixelated Pope, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, and Bokeh Dev for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.